Right now, hundreds of galaxy clusters are racing across the universe at over 2 million miles per hour, pulled by something so massive, so mysterious, that we can't even see it. Imagine that for a second. Entire clusters of galaxies, each containing trillions of stars, moving together as if tied to an invisible rope. Where are they going? What force could possibly pull them all in the same direction? And more importantly, what does that say about the universe we live in? You might think the cosmos is vast, empty, and fully understood by scientists. But the truth is, what we can actually see is just the tip of the iceberg. The universe you've been told about, the one filled with stars, galaxies, black holes, and dark matter, is only a fraction of the full story. For most of human history, the night sky looked like an endless dome of stars. But telescopes revealed that those stars belonged to just one galaxy, and beyond it lie billions more. Then came the shocking realization: the universe itself is expanding, stretching space like an inflating balloon. That expansion means the light we see from distant galaxies today left them billions of years ago, when they were far closer. The further away we look, the deeper we're peering into cosmic history. But there's a catch. That history has limits. We live inside a bubble, a sphere of visibility about 93 billion light-years across. Everything we know, every galaxy ever photographed, every distant star captured by our telescopes, exists inside this bubble. But the bubble isn't a boundary of space, it's a boundary of time. Light from beyond it simply hasn't reached us yet, and maybe never will. Which raises a disturbing question: what lies outside the bubble? Here's where things get strange. We can't directly observe beyond this horizon, but the universe leaves scars and signals, clues hidden in the background radiation, the distribution of galaxies, and the flow of cosmic matter. These signs whisper of forces and structures beyond anything we can imagine. Some scientists believe that what we see is just one bubble among countless others, a tiny pocket in a vast multiverse where physics itself might play by different rules. Others think that invisible megastructures, bigger than anything inside our observable universe, are pulling matter toward them like cosmic magnets. And then there are those who suggest that our universe might not be real at all, but a simulation, a program running inside a reality we can never reach. The deeper we look into space, the more it feels like we're staring into a mirror that hides more than it reveals. The cosmic microwave background, the afterglow of the Big Bang, acts like a wall of fog, preventing us from seeing what came before. Behind it may lie evidence of collisions between universes, scars from when cosmic bubbles slammed into each other. And if those scars are real, then it means our universe has neighbors. It means our everything is just one patch in an infinite cosmic landscape. So what does this mean for us? If galaxies are being dragged across billions of light years by invisible forces, then our entire observable universe might be just a fragment of something much larger, something so vast that even calling it infinite feels inadequate. And if that's true, then all of human history, every star you've ever seen, every planet that might hold life, could be nothing more than a tiny speck in an endless cosmic ocean. Tonight, when you look up at the stars, remember this: you're not just seeing the universe, you're seeing the edge of what's possible to see. Beyond that horizon lies a realm of hidden forces, unseen structures, and perhaps even other universes altogether. And the clues we've found so far suggests that reality is far stranger and far bigger than we ever dared to imagine. Scientists say our observable universe stretches about 93 billion light-years across, a number so staggering that it bends the limits of human imagination. To put it in perspective, light, the fastest thing we know, would take 93 billion years to travel from one end of this cosmic bubble to the other. Yet here's the paradox. The universe itself is only about 13.8 billion years old. That means light has only had 13.8 billion years to travel. So how can we possibly see objects that appear to be tens of billions of light years away? At first glance, the math doesn't add up, but the answer holds the key to one of the most mind-bending realities in all of science. Space itself has been stretching the whole time. Imagine drawing tiny dots on a balloon, then inflating it. The dots don't move across the balloon's surface on their own. Instead, the surface stretches, carrying the dots farther apart. The same thing happens in our universe. When a galaxy emitted light billions of years ago, it was much closer to us. But as that light traveled across space, the very fabric of space expanded, dragging the galaxy further away even as its light continued to travel toward us. By the time the light finally arrived, the galaxy had been carried to an unimaginable distance. What this means is that the universe we observe is like a snapshot frozen in time, showing us galaxies as they once were, not as they are now. This stretching of space creates what scientists call the observable universe, a bubble around us, defined not by physical walls, but by the limits of time and light. Inside that bubble are roughly 2 trillion galaxies, each one containing hundreds of billions of stars. Every star you've ever seen with your naked eye, every nebula captured by the Hubble telescope, every quasar blazing at the edge of detection, every single one lies inside this cosmic sphere. But here's the crucial point. The observable universe is not the entire universe. It's just the part we can see. Beyond its edges, the universe continues, vast and unbroken, filled with galaxies and structures we may never detect. It's like standing on a beach and gazing at the horizon. You know the ocean doesn't stop there. Even though your eyes can't see past that line, the horizon is a boundary of vision, not a boundary of reality. The more we study this bubble, the more it feels like a trick of perception. The 93 billion light-year figure isn't telling us how big the whole universe is. It's telling us how much of it light has had time to reach us from since the Big Bang. What's unsettling is that every observer, no matter where they stand, experiences their own bubble. If you could travel to a galaxy at the edge of our observable universe and look outward from there, you'd see a whole new sphere of galaxies invisible to us. That means the total universe is not just bigger than we think, it's bigger than we can even measure. For every cosmic horizon, there's another horizon beyond it, and another beyond that, stretching endlessly outward. This perspective reshapes how we understand our place in reality. We tend to imagine ourselves as small creatures floating in an incomprehensibly large cosmos. But even that doesn't capture the truth. The truth is that everything we can see, all the galaxies and stars combined, may be only a fraction of what's out there. We don't live in a universe defined by its contents, we live in one defined by the limits of our perception. And those limits mean that our cosmic bubble isn't the final word on reality, it's just the first clue. What lies beyond its edge, forever hidden behind the curtain of space and time, might change everything we think we know about existence. If the observable universe is a bubble, then its surface is made of fire, ancient fire, that has been frozen in time for nearly 14 billion years. Scientists call it the cosmic microwave background, or CMB, and it represents the oldest light in existence, the faint afterglow of the Big Bang itself. But here's the twist. This glowing veil doesn't just illuminate the early universe, it also blocks our view of anything that came before. To understand why, we need to travel back to the first 380,000 years after the Big Bang, when the universe was a furnace hotter and denser than the core of a star. Back then, Particles of matter and light were locked in a chaotic dance. Electrons zipped freely through space, constantly colliding with photons, scattering them like billiard balls ricocheting off each other in every direction. Light could travel only a few inches before it slammed into another particle and changed direction again. The result was a cosmos that looked nothing like the vast blackness we know today. It was opaque, a blazing soup of energy where nothing could travel freely. In that chaotic fog, no telescope, no human eye, not even the speed of light itself could cut through the haze. Then something extraordinary happened. As the universe expanded, it cooled. Electrons, moving more slowly, finally found themselves captured by atomic nuclei, forming the first complete atoms of hydrogen and helium. For the first time in cosmic history, light was no longer trapped. Photons, suddenly free from their endless collisions, began streaming outward in straight lines across the young universe. This moment of liberation, when the fog lifted and light broke free, created the CMB. Every photon that escaped then is still traveling today, bathing the entire cosmos in a faint microwave glow. When scientists point radio telescopes into space, they detect this ancient radiation coming equally from every direction. It's like standing in the center of a sphere painted with the universe's baby picture, frozen at the exact moment it became transparent. But here's the catch: that glowing surface is as far back as we can ever see. It's not just an observational limit. It's a cosmic wall. Beyond it, the universe was opaque, meaning we will never detect the light from anything that happened earlier. The first 380,000 years of cosmic history remained hidden, locked behind a curtain that no amount of technology can pierce. We cannot see the Big Bang itself. We cannot observe the formation of the very first structures. We are left only with indirect evidence, whispers carried forward in the distribution of galaxies and the subtle patterns etched into the CMB. And those patterns carry their own mysteries. When scientists studied the CMB in detail, they noticed something shocking. It's almost perfectly uniform. Its temperature is nearly the same across the entire sky, differing only by fractions of a degree. This might not sound surprising, but it should be impossible. Regions of space on opposite sides of the sky are so far apart that they could never have interacted or exchanged energy, not even at the speed of light. And yet, somehow, they ended up with exactly the same temperature. It's like filling a bathtub with hot and cold water from opposite ends, and finding that every drop in the tub instantly mixed to the same lukewarm temperature, even though there was no time for the water to spread. This strange uniformity suggests that something extraordinary happened before the cosmic wall of fire formed, something beyond our direct vision. The leading explanation is cosmic inflation, a brief period when the universe expanded faster than light, stretching space itself in a way that smoothed out temperatures before the regions drifted apart. But here's the disturbing part. If inflation is true, then our universe is just one bubble in an infinite foam, a single reality in an endless sea of others. The CMB, then, is more than a scientific relic. It is both a window and a barrier. It shows us the earliest light that exists, but it also reminds us of how much we cannot see. Beyond its glowing surface lies a hidden era of physics, perhaps even the origin of space and time themselves, forever veiled from direct observation. That veil is the ultimate cosmic limit, a reminder that no matter how far our telescopes reach, there are some mysteries we will only ever be able to guess at. And it's behind that barrier where the secrets of the infinite universe, and maybe even entire other universes, could be waiting. Look up at the night sky and you'll see a few thousand stars twinkling faintly against the dark. But those pinpricks of light are only the tiniest fraction of what actually surrounds us. Beyond them, through the most powerful telescopes ever built, astronomers have counted more than 2 trillion galaxies within our observable universe. Each of those galaxies contains hundreds of billions of stars, and each star might host entire planetary systems. The numbers are so overwhelming that they defy human comprehension. Try to count every star in the night sky and you'd reach about 9,000. Try to count every star in the observable universe and the task becomes impossible. It would take longer than the universe itself has existed. And yet here's the truly unsettling part. All of this, the stars, the galaxies, the quasars, the nebulae, every cluster of light we've ever seen through human eyes, represents only a small fraction of what's actually out there. The limit of 93 billion light-years defines the edge of what we can see, not the edge of what exists. Imagine standing in a vast desert where the horizon stretches endlessly around you. What you see is limited by the curvature of the earth, but you know intuitively that land continues far beyond your vision. The same applies to the universe. The observable bubble we live in is simply the slice of cosmic history that light has had time to reach us from. Beyond its edge lies more universe, perhaps infinitely more, filled with stars and galaxies that our telescopes will never capture. And this isn't just speculation. Geometry itself demands it. Basic math shows that if you move to the very edge of our observable bubble, your own horizon would expand to include regions invisible from Earth. An alien astronomer positioned there would see an entirely different slice of reality, with galaxies we will never detect, push farther outward. And the process repeats again and again, each new horizon revealing more and more space. This endless chain suggests something profound. The universe is either unimaginably larger than what we can see, or infinite in size. And if it's infinite, then there are infinite galaxies, infinite stars, and infinite possibilities repeating beyond the reach of our instruments. What makes this even more extraordinary is that the laws of physics appear to be universal. The same processes that formed our solar system would be happening in countless other places. Stars would collapse under gravity, planets would form from cosmic dust, and some of those planets might even evolve conditions suitable for life. Somewhere beyond our horizon, there could be galaxies identical to the Milky Way, with stars exactly like our Sun, and perhaps even planets identical to Earth. The expansion of space means we'll never see them, but the math says they are almost certainly there. And here's the mind-bending twist. Because the universe is so vast, probability dictates that exact duplicates of you and me exist somewhere beyond our cosmic horizon. With infinite stars and infinite galaxies, every possible arrangement of matter must occur, not once, but infinitely many times. That means another Earth with the same history as ours is out there, orbiting another sun, populated by people living lives indistinguishable from our own. And there are other Earths with slightly different histories, where civilizations rose and fell in different ways, where choices played out differently, where entire alternate versions of our reality unfolded. The night sky, then, isn't just a window into the cosmos we know. It's a reminder of the infinity that stretches beyond it. Every star we see is part of a grander tapestry that continues forever outward, painting a picture of a universe so immense that even 2 trillion galaxies are only the opening act. Our observable bubble is just a speck in an endless sea, and beyond its edges lies a reality that defies every limit of imagination. The observable universe may feel limitless, but it is surrounded by an invisible barrier more profound than any wall of stone or steel. This boundary is not made of matter, nor is it created by energy. It is constructed entirely out of time. The limit of 93 billion light-years doesn't exist because the cosmos runs out of galaxies, but because light itself hasn't had enough time to reach us from farther away. Space and time are woven together, and that fabric imposes a natural horizon beyond which no signal has yet arrived. Imagine living on the shore of an endless ocean, knowing vast continents lie across the waters, but the waves have not yet carried their reflections to you. That is our position in the cosmos, standing at the edge of a visible sphere, while the true expanse of reality stretches far past what we can ever directly observe. The mathematics reveal how strange this barrier really is. The universe is only 13.8 billion years old, which means that nothing should be farther than 13.8 billion light-years away. After all, that's the maximum distance light could have traveled since the Big Bang. Yet the observable bubble measures a staggering 93 billion light-years across. How is this possible? The answer lies in expansion. Space itself has been stretching this whole time, like a balloon being inflated, carrying galaxies away from one another even faster than light can travel. So while the photons from distant galaxies began their journey billions of years ago, space continued to grow beneath them, dragging those galaxies farther away as the light crossed the void. By the time those photons finally reached us, the galaxies that emitted them had receded to unimaginably greater distances. The 93 billion light-year horizon is the frozen imprint of this constant expansion. But there's a darker implication. Expansion doesn't just carry galaxies away, it also pushes them beyond our reach forever. Any galaxy receding faster than the speed of light is effectively lost to us, even though its ancient light might still be traveling toward us. The light it emits today will never cross the gulf of space. Every second, thousands of galaxies slip past this cosmic point of no return, vanishing from the possibility of contact. The universe we can observe is shrinking in practical terms, even as it grows in scale. What we see now is only a brief snapshot, a fleeting window that narrows with each passing moment. This temporal boundary creates the ultimate observational wall. No matter how advanced our technology becomes, no telescope can peer beyond the veil of time. We are confined to the events whose light has reached us, trapped inside a sphere of causality. The deeper mystery lies in what exists beyond. Just because we cannot see it doesn't mean it isn't there. Galaxies continue to shine in regions we'll never detect. Black holes devour stars, supernovae blaze into existence, planets circle suns, and perhaps civilizations rise and fall, all in realms permanently disconnected from us. The barrier of time ensures that those realities will remain forever hidden, tantalizingly close in cosmic terms, yet infinitely out of reach. This raises a haunting thought. If intelligent beings exist beyond our horizon, we will never know them. They could look up at their own sky, see their own stars, and wonder the same thing we do. Yet our universes are causally sealed off from one another. Each pocket of observation is like an island, separated by a sea of expanding space that no signal can cross. We are not just alone because of distance. We are alone because of time itself. And yet, paradoxically, this very barrier hints at the possibility that infinite realms lie just beyond our sight, expanding, evolving, and vanishing beyond reach in an eternal cosmic tide. Roughly 380,000 years after the Big Bang, the universe underwent a transformation so dramatic that it changed the way reality itself could be observed. Before this moment, space was not transparent as we know it today. It was a seething furnace of plasma, so dense and so hot that light couldn't travel more than a few inches without colliding with a particle and scattering into random directions. Photons, the very particles of light, were trapped in a cosmic pinball machine, endlessly bouncing between free electrons and protons. The entire universe glowed like the inside of a star, but that glow was inescapable, blinding, and impenetrable. If you could somehow have stood in this primordial cosmos, you would have seen nothing but a blinding fog stretching in every direction, with no possibility of glimpsing anything beyond your immediate surroundings. It was an opaque universe, a cage of light, where vision as we know it simply did not exist. Then something extraordinary happened. As the universe expanded, it cooled, and with cooling came change. Electrons, once too energetic to settle into orbit around nuclei, began to slow down just enough to combine with protons. For the first time, complete atoms formed, and with that single step, the universe became transparent. Photons were no longer constantly scattered. They were free to travel unhindered, streaming across space in straight lines. This sudden release of light burst outward in every direction, creating what scientists call the surface of last scattering. That light is still traveling today, stretched by billions of years of cosmic expansion, and we detect it as the faint glow of the cosmic microwave background. It is the oldest light in the universe, a silent witness to the moment when the cosmos unveiled itself for the very first time. But this ancient glow is not just a relic of the past. It is also the ultimate barrier of our sight. The cosmic microwave background represents the farthest back we can ever see. Anything that happened before 380,000 years after the Big Bang remains forever hidden, locked away behind the opaque fog of that earlier plasma. We cannot observe the universe in its infancy, cannot see the moment of its birth, and cannot peer directly into the primordial processes that shaped it. The wall of fire, as it is sometimes called, marks an observational horizon no telescope will ever cross. It is the universe's original curtain, separating the visible cosmos from the unobservable one. What makes this barrier so puzzling is what it shows us. The cosmic microwave background looks almost perfectly uniform, the same temperature in every direction across the sky, varying only by tiny fractions of a degree. This uniformity is baffling. Regions of the early universe that were never close enough to exchange heat somehow ended up at the exact same temperature. It is as if two fires started on opposite sides of the Earth without any contact, yet both burned with identical intensity, producing flames of the same heat. This smoothness suggests that something extraordinary happened before the wall of fire formed, something that smoothed out the energy distribution of the universe and imprinted its fingerprints on the light we now see. That mystery points directly toward a deeper reality that lies beyond our ability to observe. The cosmic microwave background is therefore not just a barrier, it is a message. It tells us that our universe once experienced conditions we cannot see, events hidden behind that glowing veil, processes that shaped everything we know but remain inaccessible to our instruments. And yet, paradoxically, this barrier is also a gift. Without that ancient glow, we would have no way to study the conditions of the early cosmos. Those faint microwaves, stretched to nearly invisible wavelengths, still carry a record of the primordial universe, whispering secrets from nearly 14 billion years ago. We are left with the tantalizing truth. The wall of fire is both the edge of our sight and the greatest clue to what lies beyond. Count the stars in the night sky with the naked eye and you'll find only a few thousand glittering points scattered across the darkness. Bring the most powerful telescopes ever built into the picture, and that number explodes into trillions of galaxies, each containing hundreds of billions of stars. The sheer scale of our observable universe is almost incomprehensible. 2 trillion galaxies, each one a city of suns, stretching across 93 billion light-years of space. Yet here's the staggering truth. Even this unimaginable abundance is barely a fraction of what exists. The bubble of visibility we live in is just a drop in an endless ocean, a narrow window onto a universe that refuses to reveal its full face. And the evidence doesn't just suggest this, it practically guarantees it. Imagine standing on a beach at sunrise, watching the horizon stretch across the sea. You can see perhaps 20 miles before the Earth's curvature blocks your view. But you know without question that the ocean doesn't end at the horizon. It continues for thousands of miles, filled with continents, islands, storms, and mysteries you'll never glimpse from your shore. The same principle applies to our cosmic horizon. From our perspective, the observable universe defines everything we can detect, but if you traveled to its edge, you would gain a new horizon of your own. From that vantage point, an entirely different sphere of galaxies would come into view. Galaxies invisible to us here on Earth, yet perfectly real. Repeat this process across infinite directions, and the conclusion becomes unavoidable. The universe extends far beyond our line of sight, perhaps without end. The strangest part of this realization is that the universe doesn't just continue, it expands faster than light can travel. Galaxies near the edge of our visible bubble are already receding at nearly light speed, while those just beyond are moving away faster than light itself. We can never see them, no matter how long we wait or how advanced our telescopes become. They exist in a region of space forever cut off from us, a realm that is causally disconnected from our own. In essence, we are trapped in a cosmic bubble, unable to send or receive signals from the infinite expanse beyond. This isn't just distance, it's a fundamental isolation imposed by the expansion of the cosmos. What makes this even more compelling is the evidence of flatness. Measurements of the cosmic microwave background show that on the largest scales we can observe, space is remarkably flat. A flat universe implies one of two things. Either it is infinite in size, stretching endlessly beyond our bubble, or it is so unimaginably vast that any curvature is too slight for us to detect. In either case, the implication is the same. Our observable universe is not the full story. Somewhere beyond our horizon are countless other galaxies, stars, and perhaps even civilizations, living their entire histories in regions we'll never reach. This raises a haunting paradox. Every second, thousands of galaxies slip permanently beyond our sight as cosmic expansion carries them away faster than light. The night sky is filled with light from galaxies that may already be gone, erased from our future view forever. What we see is not the universe as it is, but as it once was, and much of it is already lost to us. The galaxies vanish not because they die, but because the fabric of space itself carries them into darkness. Our cosmic window is constantly closing, even as new light from distant stars continues to arrive. The conclusion is as humbling as it is profound. The observable universe is not the universe itself. It is a tiny, fragile bubble of visibility in an ocean without end. We stand on the shoreline of infinity, gazing out at a horizon that hides more than it reveals, and the truth is inescapable. Most of reality is already beyond our reach. When astronomers mapped the motions of galaxy clusters across billions of light years, they expected to find the same simple pattern written into the laws of cosmic expansion, everything moving away from everything else, each cluster receding at a speed directly proportional to its distance. It should have been uniform, predictable, and boring, like dots painted on the surface of an inflating balloon. But in 2008, a discovery shook that assumption to its core. Hundreds of galaxy clusters weren't spreading evenly. They were streaming in one direction, racing through space at over 2 million miles per hour toward a patch of sky between the constellations Centaurus and Vela. This bizarre motion wasn't caused by the normal expansion of space. It wasn't the result of nearby galaxies tugging gravitationally on each other. It was something deeper, something more disturbing. NASA scientists called it dark flow. Dark flow defies the basic framework of cosmology. Nothing inside the observable universe contains enough mass to pull galaxy clusters across such vast distances at such incredible speeds. Not even the combined gravity of every galaxy, every cluster, every black hole, and all the dark matter we can detect would be enough to explain this strange migration. The force driving these clusters doesn't seem to come from within our bubble at all, it comes from outside it. In other words, galaxies are being dragged by something beyond the edge of the observable universe, something we cannot see, measure, or identify. Think of leaves floating down a river. You see them moving, carried along by an invisible current. You can't see the waterfall upstream, but you know it must be there, shaping the flow. Dark flow is the cosmic version of this puzzle. The leaves are galaxy clusters, and the current pulling them doesn't originate in our visible reality. Some theorists suggest it might be the gravitational effect of unimaginably massive structures that formed during cosmic inflation, compressed into scales so enormous that they dwarf everything inside our universe. These structures could contain the mass of millions of galaxy clusters, hidden forever beyond our horizon. Others take it further, speculating that dark flow could be evidence of parallel universes, with their gravity bleeding across cosmic boundaries into our own. For skeptics, dark flow might simply be an illusion, the result of measurement errors in mapping the cosmic microwave background. Yet the data stubbornly persists, and independent studies continue to find hints of the same strange motion. If real, it suggests that our universe is not an island floating alone in a sea of nothingness, but part of a vast cosmic archipelago where neighboring universes leave scars and currents that ripple into ours. The very idea unsettles our sense of place. We like to imagine the cosmos as a closed system, a self-contained bubble where everything can be explained by known physics. Dark flow tears at that illusion. It whispers that something unimaginably massive is tugging at us from the outside, a hidden force shaping our fate. Whether it is the relic of ancient structures born in inflation, the gravitational shadow of a multiverse, or something stranger still, one truth is unavoidable: galaxies are not drifting randomly, they are being pulled. The universe is showing us that beyond the edge of sight, reality continues, and it may be far stranger than anything we've ever dared to imagine. Deep in the constellation Eridanus lies a scar in the universe, so massive that it stretches nearly 2 billion light-years across. Astronomers call it the CMB cold spot, a region in the cosmic microwave background that is inexplicably colder than the surrounding space. At first glance, this might seem like a minor temperature dip, just a faint bruise on the afterglow of the Big Bang. But when scientists studied it more closely, they realized it was far too large, too structured, and too improbable to be explained by chance alone. In fact, the cold spot represents one of the most perplexing anomalies in modern cosmology, and some believe it could be the fingerprint of another universe crashing into our own. The cosmic microwave background, or CMB, is the oldest light we can detect, a faint radiation left behind from when the universe became transparent, just 380,000 years after the Big Bang. It's supposed to look nearly uniform across the sky, with only tiny fluctuations in temperature, fractions of a degree, that seeded the formation of galaxies and cosmic structures. But the cold spot isn't tiny. It spans a vast patch of the sky, and the drop in temperature is too great to be explained by random statistical noise. Imagine pouring a perfectly even layer of sand onto a flat surface, only to find a massive crater right in the middle. That's what the cold spot looks like when mapped onto the background radiation of the cosmos. Some astronomers argue that it might be caused by a cosmic void, a region of space unusually empty of galaxies and matter. Photons passing through such a void would lose energy, cooling slightly as they travel, but even the largest known voids are not big enough to account for the scale of the cold spot. This leaves researchers searching for more exotic explanations, and one possibility stands out as both thrilling and unsettling. The cold spot might be the scar of a collision between our universe and another. According to the theory of eternal inflation, Our cosmos is just one bubble among countless others in an infinite multiverse. Occasionally, these expanding bubbles of space-time could collide, leaving permanent imprints on their structures. The cold spot, with its size and shape, fits the predicted signature of such a cosmic crash. If true, it would be the first observational evidence that our universe is not alone, that others exist just beyond the horizon of what we can see. Of course, the idea of bubble universes colliding raises more questions than answers. What lies beyond that scar? Did another universe with different physics brush against ours in the distant past, leaving behind a bruise we can still detect billions of years later? Could that neighboring universe still exist, separated from us by an ever-expanding gulf of inflating space? Some simulations suggest these collisions could warp the fabric of reality itself, creating rings of distorted temperature in the CMB, echoes of an ancient impact that transcend comprehension. Skeptics continue to search for less dramatic explanations, arguing that until better data emerges, the cold spot remains a puzzle rather than proof of the multiverse. Yet even the skeptics admit it represents one of the strangest features ever observed in the early universe. Whether caused by a massive void, a cosmic glitch, or the shadow of another reality, the cold spot serves as a reminder that the universe still hides secrets in plain sight. When we look into that dark patch of the sky, we may be staring at the first clue that our reality is just one of many, a single bubble drifting through a foaming sea of infinite universes. One of the most mind-bending truths about the universe is that while nothing with mass can move faster than light, the fabric of space itself doesn't follow that rule. During the earliest moments of the Big Bang, the universe experienced a phase called cosmic inflation, a blistering expansion where space ballooned faster than light could ever travel. In less than a fraction of a second, regions smaller than a proton stretched to sizes larger than galaxies. This inflationary growth didn't move objects through space, it created more space between them, a loophole that allows the cosmos to outpace light without breaking the rules of relativity. And that faster-than-light expansion hasn't really stopped. It still drives galaxies at the edge of our observable universe away from us so quickly that their light will never reach Earth, no matter how long we wait. To picture this, imagine two ants standing on the surface of a balloon. If you inflate the balloon slowly, the ants notice each other drifting apart, but could, in theory, still crawl across the surface to meet. But if you blow the balloon up fast enough, the distance between them grows faster than they could ever crawl. That's exactly what happens with galaxies on the farthest edges of the universe. They aren't traveling through space faster than light, but the space between us and them is expanding so rapidly that any attempt at communication becomes impossible. They are slipping beyond a cosmic event horizon, a boundary similar to what exists around a black hole, where no information can escape across the divide. This has staggering implications. It means that with each passing second, entire galaxies filled with billions of stars and possibly trillions of planets disappear forever beyond our reach. They don't vanish in reality, they continue to exist and evolve, but they become cut off from us by the relentless stretching of space. Our observable universe, the bubble of light we can see, is not fixed. It shrinks in significance every moment as the expansion pushes more of reality into permanent exile. What we think of as the universe is actually a constantly changing window, a fading glimpse into an endless cosmos that slips away faster than we can comprehend. The speed of light, once thought of as the ultimate cosmic limit, suddenly feels small when compared to the raw power of expanding space. During the inflationary epoch, space grew so quickly that regions that were once in contact suddenly became separated by distances larger than light could cross. This neatly explains one of the greatest mysteries of the cosmic microwave background, why it appears nearly identical in every direction. Without inflation, regions of the universe that were never in contact shouldn't have reached the same temperature, and yet they did. Inflation allowed them to interact before ripping them apart faster than light, freezing that uniformity into the fabric of the cosmos. But here's where the story gets even stranger. Inflation may not have been a one-time event. Many cosmologists believe it never ended. It still continues in vast regions beyond our observable universe, endlessly creating new bubbles of space-time. If true, that means our universe is just one pocket among countless others, each born from the same faster-than-light expansion that tore ours into existence. Some of these bubbles might follow physics identical to ours. Others could be radically different, with alternate versions of matter, forces, and dimensions. And because inflation expands faster than light, most of these universes are forever disconnected, unreachable no matter what technology or intelligence might evolve within them. This paints a haunting picture. We live in a reality where space itself is the fastest thing in existence, forever creating, stretching, and separating worlds. Our galaxy, our stars, even our lives are bound to a bubble that grows increasingly isolated as time marches on. Beyond the horizon, whole universes are being born at this very moment, but they will remain forever hidden, racing away into a darkness faster than any light could ever chase. When we think of the Big Bang, we often picture it as a singular explosion, a one-time event that marked the birth of everything we know. But modern cosmology suggests that this event may not have been unique at all. Instead, it could have been just one bubble forming in an infinite sea of inflation, one universe among countless others in a process that never truly ends. This concept, known as eternal inflation, describes a cosmos where the expansion that created our universe continues endlessly, spawning new realities without limit. In this view, our observable universe is just a patch in a much larger quilt, stitched together from countless regions of space-time, each with its own history, physics, and destiny. The mechanism behind this is both simple and mind-shattering. At the core of inflation lies a field of energy called the inflatum. In the early universe, this field dominated everything, driving expansion faster than the speed of light. But the inflatum isn't stable. It decays randomly, like radioactive material, and when it does, the energy locked inside converts into matter and radiation, creating a hot, dense bubble that looks very much like the Big Bang we associate with our own cosmos. Our universe was born when inflation stopped in our region of space, but in most regions, inflation didn't stop. It continues even now, producing more and more bubbles that each undergo their own Big Bangs. This process never halts, making inflation eternal. Think of it like boiling water. Each bubble that forms in the liquid represents a new universe. Some bubbles pop, some grow, some merge, but the boiling never stops. In the same way, new universes continue forming within the inflating multiverse, with no end in sight. The sheer scale of this is impossible to fully grasp. With infinite time and infinite space to work with, eternal inflation ensures that not only will countless universes exist, but every possible configuration of physics, particles, and even histories will be realized somewhere. That means there could be other universes identical to ours, with galaxies, planets, and even versions of you reading these very words. And beyond those, there will be universes completely alien, where the laws of physics bear no resemblance to our own. What's even more extraordinary is the randomness of the process. Quantum fluctuations, the same strange probabilistic events that dominate the quantum world, determine when and where inflation ends and a bubble forms. These fluctuations happen everywhere, all the time, ensuring that bubble universes continue to appear forever. Our universe is one outcome, a single roll of the cosmic dice, and within the multiverse every roll eventually happens. This leads to staggering consequences. If the multiverse is truly infinite, then every event that can possibly occur not only happens once, but happens an infinite number of times. Every choice you've made, every fork in history, every path not taken, is realized in some other bubble reality. The mathematics behind eternal inflation leave little room for doubt. Once it begins, the process cannot stop. Even as bubbles form and create universes like ours, the background space keeps expanding faster than bubbles can fill it. This means most of reality remains in a perpetual state of inflation, while within it, bubbles continue to nucleate infinitely. It's a self-replicating machine, a cosmic engine that produces new universes endlessly. From this perspective, our universe is not special, not even rare. It's just one of countless offspring in a family that has no beginning and no end. The implications are as profound as they are unsettling. If eternal inflation is real, then the multiverse is not speculation but necessity. Every possibility is played out somewhere. Every version of history exists, and the birth of new universes continues even now, beyond the veil of what we can observe. The Big Bang wasn't the beginning of everything, it was just our beginning, the spark that lit our bubble in an infinite froth of creation. Out there beyond the edge of our cosmic horizon, bubbles are forming at this very second, each one a new universe filled with stars, galaxies, and perhaps even life. Eternal inflation guarantees that the story of reality is not a single narrative, but an infinite library, with every page, every chapter, and every ending written into existence. As we push deeper into the mysteries of the multiverse, one of the most haunting ideas is that entire universes may be born inside the death throes of stars. Black holes, those cosmic monsters that swallow everything crossing their event horizons, may not be mere endpoints of matter and energy. They could be gateways. The traditional view paints black holes as bottomless pits, where matter collapses into a singularity, a point of infinite density and zero volume, where our known laws of physics collapse. But modern theories suggest something much more complex, even elegant, that the singularity might act as the seed for a new universe. In this scenario, every time a massive star collapses into a black hole, it could be giving birth to an entirely new bubble of space-time, one with its own laws of physics, its own galaxies, and possibly its own intelligent beings wondering where they came from. To understand this, imagine a black hole as a one-way door. From our side, anything that crosses the event horizon disappears forever, crushed by gravity's relentless pull. But from the inside perspective, time doesn't stop. Instead, the collapse could trigger inflation, similar to the process that began our universe. Matter falling inward may not compress into nothingness, but instead explode outward into a new expanding reality. From our vantage point, the black hole looks frozen in time, but from within, a new cosmos unfolds. This idea transforms black holes from destructive voids into cosmic wombs, recycling old matter into fresh universes. Theoretical physicist Lee Smolin went a step further by proposing a model called cosmological natural selection. In his view, universes that produce many black holes also produce many offspring universes. Those universes pass on their physical laws, but with slight variations, much like genetic mutations. Over time, natural selection favors universes that are particularly efficient at creating black holes, and those universes dominate the multiverse. Our universe, with its billions of black holes scattered across countless galaxies, may simply be the successful descendant of many generations of cosmic ancestors, each tuned by evolution to maximize reproduction. This could explain why the laws of physics in our universe seem so perfectly balanced for the existence of stars, galaxies, and life itself. The balance isn't accidental, it's the result of cosmic evolution. What makes this possibility even more breathtaking is that black holes in our universe could already contain countless universes hidden beyond their horizons. Each black hole may be the birthplace of a reality larger than our own, yet invisible to us because its expansion is trapped behind a cosmic curtain. From the outside, we see only darkness. From the inside, there might be stars and galaxies forming in a space-time that will never touch ours. This possibility flips the narrative of cosmic death on its head. Instead of representing an ending, black holes could be the beginning of infinite new stories. But as with all things in cosmology, the mystery deepens. If black holes spawn new universes, then perhaps our universe was itself born from a black hole in some other higher reality. Our Big Bang might have been the singularity of another cosmos collapsing inward, and the laws we observe, gravity, electromagnetism, nuclear forces, might have been inherited from that parent universe with slight modifications. This places us in a lineage of universes, stretching backward and forward through eternity, each generation birthing the next in a cycle of collapse and creation. Yet even with this elegant vision, we remain blind to confirmation. The event horizon is an impenetrable barrier, preventing us from observing what happens beyond it. All we can do is follow the mathematics and trace the implication. If true, it means the multiverse is not just an abstract idea born from inflation theory, but a living system, constantly reproducing itself through the very processes of birth and death that shape the stars we see. Every black hole in the night sky could be a cradle for a new universe, and somewhere within those hidden realms, there may be beings staring at their skies, wondering if they too were born from the collapse of another world. Here's the conclusion, written as one flowing narrative with no segmentation and more than 500 words. When you step back from the details, from cosmic strings slicing reality to black holes seeding new universes, from dark flow dragging galaxies toward an unseen abyss, to the haunting symmetry of mirror worlds where time itself runs backward, one truth emerges with astonishing clarity. Our universe is not the final story, nor is it even the whole stage. What we see, this 93 billion light-year wide bubble of stars, galaxies, and cosmic light, is only the smallest glimpse of a far grander reality, one so vast that it makes even the wildest human imagination feel timid. The multiverse is not just a scientific speculation, it is a natural conclusion drawn from the mathematics of expansion, the mysteries of the cosmic microwave background, and the strange precision of the laws of physics that govern our existence. If there is one theme that threads through everything, it is that the cosmos refuses to be confined, and every time we think we have reached the edge, the horizon moves further away, revealing that what we once called the ultimate truth was just the beginning. The conclusion, then, is not an ending, but a perspective shift. The universe we call home is one of countless others. Some may be eerily similar, with galaxies and planets and even beings that resemble us in almost every way. Others may be so alien that no metaphor from our world could capture them. Universes with 10 spatial dimensions, realms where electromagnetism works in reverse, or bubbles where consciousness directly sculpts reality. In some of these, stars never form. In others, life flourishes under laws of physics that seem impossible to us. And beyond those, there may be worlds created not by natural laws at all, but by advanced civilizations capable of simulating entire realities, leaving us with the haunting possibility that we ourselves might be living in code. Yet, as unsettling as these ideas sound, there is also a strange comfort in them. They tell us that existence itself is not fragile or fleeting. It is endlessly renewed, endlessly branching, endlessly experimenting, even as our own universe marches toward its eventual heat death. With galaxies drifting apart and stars burning out, the multiverse ensures that countless others are being born. Somewhere, right now, new Big Bangs are igniting. Somewhere, matter is coalescing into new galaxies. Somewhere, beings are asking the same questions we ask, looking into their skies with the same mixture of awe and confusion. The cycle never ends. Creation and destruction are not opposites, but partners in a dance that has no final act. What remains for us is not despair at our smallness, but wonder at our participation. Against impossible odds, in one bubble among infinite others, conditions aligned perfectly to allow life, thought, and consciousness to arise. Out of all the cold possibilities, we are here, able to perceive and ask questions about the cosmos. That fact alone is as miraculous as any multiverse theory, because it means that awareness itself, something that could have been absent, exists. And perhaps awareness is not a mere byproduct of the universe, but one of its defining features, the very thing that allows realities to solidify from the haze of quantum potential. If that is true, then every observer, every question, every act of curiosity adds another thread to the infinite tapestry. So, the conclusion is not that we have solved the universe, it is that the universe and the multiverse beyond it cannot be solved in any final way. There will always be new mysteries hidden beyond the horizon, new anomalies in the data, new theories that stretch our comprehension. And maybe that is the point. The cosmos is not a puzzle to be completed, but an eternal journey. For every answer we uncover, 10 more questions will rise. For every limit we think we've reached, reality will show us that we were only standing at the threshold of something larger. The multiverse is not an explanation that closes the book. It is the book itself, infinite pages unfolding endlessly, each one containing its own story of stars, galaxies, and lives. We are not at the end of that story. We are only on one page, one line, one fleeting but extraordinary sentence in an eternal epic that will never stop being written.